Chapter 14 is stacks and queues. Another very, very useful data structure and some algorithms that related with it. We've been talking about efficiency, right? We've been talking about how we measure it and how we are measured. Mostly, we've been talking about how we measure in time, right? How is it the constant time, which is a big O1? Is it the log time? Is it linear time or quadratic time? And so every time when we do some calculations and we have some code and we want to find out how efficient the code is. And so we have some of the assumptions that we assume that every single statement takes the same amount of time to run, and then the method called runtime is measured by roughly the total number of statements inside the method. In particularly for the loop, if the loop repeats, say, n times, and then the runtime will be related to how many times we will loop, and we will count how many times the statement in the loop will be repeated. And so here is some of the methods. And so far we've been studying the kind of a linear data structure-ish. So it's like ArrayList. We study the set, the map. They still kind of linear data structure-ish. And almost all of those data structure, we have add method. So corresponding to the map, it's put. So it's the same idea. And we have search, try to find the if we have some values in the data set. And we also want to return or get rid of some of the values from the set. So every time when we do those things, and we always want to ask the question to say how fast each of the methods goes. So it really depends on the data structure, okay? It really depends on the data structure. So that's why for some applications, maybe we want to choose the data structure that they can add things very fast. Or we want to choose data structure that can find things very fast. So we're talking about the search and sorting algorithms last week. So it really, every time when we do choose the different data structures, it really depends on what application we want to use the algorithm for. So now here comes the stacks and queues. Stacks and queues is that the stack is just like the pictures here, right? And we have a data structure, kind of like linear too. And when we want to add things, and we just say we push them into the data structure. Okay, we can keep pushing them, and then when we want to pick one out and pop them, we actually pop the top one out. Okay, so we have the the order of the stack is that whoever comes in first will be in the bottom. Whoever comes in the last will be on top. So this is really what we call, the first in, last out. Okay. The data structure is really focused on, we get the top items out. And so that's a stack. It's very easy to understand. Okay, so it retrieves elements in the return of the order they were added. And for the queue, it's very similar, except that we add the things, same thing. We add things in order, and then. All right. Not you. Everyone, I'm talking. Can you mute yourself? Hello. Everyone, mute. All right. That's better. Okay. For the queue, it is very similar, except that we all add things into it, right? And then we have the one that added first. We can call those like front of the line, and the one that added the last will be in the back of the line. All right. So when we want to remove item from the queue, and then we take the first one and we remove them. So this is really in order that it is first in and first out. And the reason we are doing this one is that, again, as we said, there isn't really any database that can solve, a problem the quickest one. It really depends on the applications. So that's why we say sometimes it is very good to choose a data structure that is really good just for certain operations. It's not for all operations, but it's only for certain operations. For example, if you want to really find out who sits in the last, right? Then stack is a very good one, because you can do that in constant time. You don't care how long the line is, right? Every time you just care, who is the last, then use the stack. And then, or sometimes you want to find out who's the first, and you're using queue. So stacks and queue, it's not try to solve every single problem. It's just targeting to perform some certain operations very quickly. So if we go back to the method here, right? If we go back to the universal like methods data structure provides, right? So we are not trying to targeting every single method to be the fast. Okay, we probably just choose to say, okay, remove will be very fast, and or maybe just add is very fast, right? So like the ArrayList, the add, it's very fast because you always add at the end of it. In related with stack and queue, and we'll introduce a concept called abstract data type, short for ADT. It is specification of connection of data and the operations that can be performed on it. So it's the reason it's called abstract, it's because it really won't tell you how it does it, okay? So it hiding the implementation details from the user. It just tells you what this data type is, what kind of method they have, what kind of operation they have, what can they do for it. So that's an example, like a stack and queue. We will actually later on try to digging out how the data structure is implemented. But from a using standpoint of view, we don't really care how stack or queue is implemented, and we don't want to know. But we just want to know how we can use it, how the operation is performed, and how can we can apply with it. So if we really, really want to know, it's really like the stacks are usually implemented with arrays, and queues are often implemented using a linked list, which we're going to study later. It's very kind of a good question one student asked me once after we study all those good data structures like ArrayList, the set, map, and now you study the stack and queue. And then it's very good in solving some problems. And so a student asked me the question, say, oh, so we learned this, then we don't have to do array anymore. And I was like, that's not the case. Actually, array, it's so basic. Almost all the data structures is built upon the arrays. Okay, so go back to the basic Java class. Array, it's so fundamental, so important. It's different database. It's just some more intelligent way to use array. So that's kind of their relationship. So we kind of say, all right, array is a basic, but it's not good enough. And we need to build much, much more complicated and useful, powerful data structure, or in Java words, they call collections, by using array in a smart way. So that's a concept about abstract data type. And again, we don't really want to know what has been, stack created, the stack and the queue, what's underneath the hood. We just want to know what the stack is, what the queue is, and what we can use it for. So the characteristics of stack is last in, first out. They call LIFO. Okay, and the three major operators is we push. That's the method name. We push them in on top of the stack, and we pop, which means we remove the top element, and peek. Peek is just take a look of the top element without changing anything. Okay, so the differences between pop and peek is that pop is just go ahead and grab it and remove it, and peek it's just take a look of the top element and maybe examine it to decide if you want to remove it or not. And the places we're using stack is quite a lot. Okay, one major things is in almost every computer languages we have a method call, or sometimes we call routine calls or function calls. And all the method calls in Java are placed onto stack. Okay, and so that means when we call, it's like a recursion, right? You put into every time when you want to call a method, you put them into stack, and then when you call a method again, you put them into stack, and then when we want, after we finish one function and we need to return that function, which means that function is finished, then that really is a pop operation. Okay, and so it's a stack. We use inside the way that the computer languages has been implemented is they using stack to handle the method call. And for compiler, which is that the compiler is also software that they use to interpret the syntax of the languages. They are using the stacks too when we try to say putting the expression, right? If we have an expression, particularly if we have a parenthesis, we have orders that plus has a lower order than multiplication. And so the evaluation of that expression, it's also using stack to do it. And another thing is that maybe we'll learn is how we can match, right? Or we want to match all the closing parentheses, closing square bracket for array, and then the closing curly braces for blocks. And that can be done using stack pretty efficiently. And the backtracks also using stacks to do it. Okay, so when we try to do the search and going through a maze, and so it's always like the last thing, the last time we will remember our last try, we say, okay, so this is a deadline, then we go back to the last one to see which one is still available, and then we go search that path. So that's also us using stack to implement it. And we'll see some of these examples pretty soon. Again, so here is the method, and the stack is capital S is capitalized, and then we have the arrows and give a type. This type has to be a class, and that will construct a new stack, and with the type of E. So the E can be a string, it can be the wrapper class of integer, wrapper class of double. And the push will give the value. We will place one value on top of the stack. And pop is remove the top of the stack and pick. Okay, so the method. And the size, it returns the number of element in stack, and also there is a very useful method called isEmpty. It will return true if the stack has no element. And here is an example of an integer stack here. So we using the first line here, stack, and then it's arrow pairs, right? And then we give integer, which is the class type here, and the S is in the stack object name, and then we using new, and then stack followed by the parentheses, and this actually calls the stack constructor. And so we can do a push, so s.push, and we push each numbers in. And then we can pop. So when we pop, and 17 is the last one we pushed in, so it's actually prints 17 out. Now, we really cannot loop over a stack, okay? That's not really the way we are doing it. And what's the way we're doing it is we check to see if the stack is empty or not, okay? So we don't, stack doesn't have the get. It's a pop. It insists that you only get from top of the stack. Okay, so this is typically the way we are doing it, is we say if the stack is not empty, then we can always, you know, pop the top one out and do something with it, and pop the top one out and do something with it. And that's the way we kind of can process every single element in the stack. Okay, so here is some exercises thing we can do. Is let's just say we have a file of scores, right? And we, so this is a kind of the example here. And we want, this is an input file, and with the scores in the name is reverse order. Okay, so it's kind of like from the last name, and Y starts first. And what about you want to print them in the alphabetic order, or you yeah, let's just say you want to reverse things in another order. Okay, so how can we do that? We'll do that in Codiva soon. Let's just see. All right, let's just see how can we do this one. Okay, so this is a quite simple exercise here. Let's try it. So everyone, you can open up the Codiva, which I'm gonna do, and hopefully today Codiva works, because Monday it didn't work. So let's go Codiva. And we have data structure and algorithms. So in here, I can add a new one. And now we are in 14. And so I can say this reverse. Okay, we'll do reverse print. Then let's just create. Okay, so you can see that I have a chapter 14. I want you guys to follow me, okay? So here we will do public. As we learned before, in order to use stack, and we need to import java.util, okay? And because that the collection is in the utility. So let's first try to do constructor. So we'll say stack. We'll do integer first. Integer, let's just say this is the ID equals new stack integer, and followed by the parentheses, and that create a new stack. It's an empty stack. And then we can do id.push. So let's push something a little bit higher. You know, the order is, we'll do 300, okay? And then ID dot push, and then we'll do 240, right? And then ID dot push. And so it's kind of a reverse order, right? 120. Okay, let's just put 3 in them. So if we want to see what is in the stack, okay, you can do that. You can just print this out, and because this is a call to string method, right? This is a call the to string method. So if we want to just run this, I have an arrow. Oh, it's not good. Selection didn't work. Selection sort. Cannot find the symbol. I probably spelled it wrong. Selection sort. All right, it's misspelled. Yeah, that's my guess. All right, so now this is okay. Array to string. Do I need to import? Java.util.string, and that's better. So selection. Oh, select with C. Thank you. Select with C. That sounds better. All right. I'm not gonna run the selection. I'm gonna run this one here. So that's normally the case. If I had arrow in one examples, they won't let me continue. So now it should be okay. Here, see, this is a stack. All right, it print out the stack, you know, whatever we gave to them. So this is the stack that we have here. All right. Now, what's the order? The order is, this is the bottom, this is the top, right? So what if I want to do a reverse print? So as the book says, we say while ID that is empty. All right, so is empty is true. So we need to use not to say if it's not empty, right? And then we'll do something. And then we'll do system.out print 9, okay? And we can print id.top. And so if we do this way, it will actually print them in the reverse order. So now if I run it, it's supposed to print 120 first, and then 240, and then 300. You see that? So we'll print them into the reverse orders. I will stop the recording here.